My name's Steve Wood. I'm a principal TME in the intent-based networking group. Work primarily in SD-WAN and cloud integration with SD-WAN. And so that's what we're going to be talking about today. All right. We're going to have a couple things. I'm going to walk through some of the use cases and some of the technology here. And at the end, we're going to have about a 5-minute demo. I'm going to switch to a colleague of mine, Aaron Royans, who's on the call here, in order to give a quick demo of how some of this stuff is working. Right. So I want to talk first and set the stage about, what are the key components here of a multi-cloud offer from Cisco, right? So you probably know all the Cisco products inside out. I get that. When we're moving to the cloud, we're talking about trying to change the resource model, the way to think about how we're deploying here. We're moving to more consumption and as a service type model, a more on-demand hosted model, where we're trying to manage more and more of the infrastructure for the customer. Okay, so we have a couple of components here that we talk about, a couple of resources we talk about. We talk about the Cisco Cloud Hub. Now you may remember SD-WAN Cloud On-Ramp. We've had a number of iterations. Cloud Hub is kind of now our latest and greatest iteration of on-ramp, but it's much more than on-ramp originally was, at least in its original incarnation. So what this really is an SD-WAN endpoint integrated with the cloud edge. All right, it's a C8000V based offer. Okay. But we have deeper cloud native integrations with all the different CSPs. I'm here to talk specifically about Google today, but we have with all the CSPs deeper native integrations now with CSP networking and with the cloud hubs that are available in most of the cloud providers. All right, so what we're trying to do is to provide a cloud edge so you can aggregate your SD-WAN directly into the cloud, and basically then we want to furthermore abstract the cloud networking. So we want to basically give you access to the backbone, allow you to even integrate with application service meshes, provide segmentation and security in a similar kind of familiar way that you would think about it if you're building sort of an actual physical network. Okay, so we're trying to basically give you that familiarity and at the same time take away some of the CLI type portal based static route manipulation that you have to do in the cloud. It's very cumbersome. We're trying to automate a lot of that and abstract that if we can. So that's where the Cloud Hub comes in. All right, so that's the SD-WAN edge in the cloud. Then this new product that we're bringing out right now, we call the Cisco Interconnect Gateway. And again, this is now Cisco's middle mile solution. So this is our solution for hosted SD-WAN at co-location facilities. Again, C8000V based. Okay, we're trying to go with more an elastic model, an on-demand model where basically we're hosting a CSR 8000V based service with a colo provider. Our first provider or our first provider is going to be Megaport. We're also in the works of development with Equinix as well, and we're going to use their backbone networks to help us do middle mile networking. We'll talk a little bit more about that. So it's a hosted, so on-demand SD-WAN and cloud access type of solution. And we're really looking here at building a cloud exchange. Okay, so we have SD-WAN, we have Cloud Direct Connects, and then we have Umbrella SIG. We'll have Umbrella SIG support and SaaS support. So what we see is that these colos, it's a great place where we have a service exchange, but there's a lot of different types of direct pairing, and we want to use our Interconnect Gateway to basically solve that problem, to basically unify that direct pairing. Now we also have as part of our offer, of course, Cisco SIG, and you just heard Jamie talk a lot about that. I put that on the play here because that's a key and important part of our overall offer. But I'm not going to speak in any detailed way about SIG. We've already kind of done that. All right. Okay. So let's talk about our Cloud Hub design with Google NCC. So what we see here is just a basic overview of kind of the architecture of the design, okay, or of our service. So we're basically based on a transit VPC architecture, and you can see here we have clusters of SD-WAN hubs that you basically be placing in different regions. The customer can basically instantiate these using vManage, right? And we can now connect these regions using the GCP backbone, and we can also connect them to workload VPCs as well. And we're going to be using the Cisco NCC Hub in order to do that, all right? So let's take a look at how that works. So what we can do is basically we're going to establish spoke VPCs or spokes into the NCC Hub. So we'll register our SD-WAN clusters as spokes. We'll register the customer workload VPC as a spoke into the NCC Hub. And once we do that, the Google magic what Google Magic does is basically allow routes to be shared between the different Google Cloud routers in the different VPCs and in the different regions, okay? And so what we need to have is global routing enabled within our VPCs and also within the workload VPCs, and then we can basically access workloads in any region or any VPC anywhere that's connected to the Google backbone network. So once we've got that connectivity with NCC Hub in place, okay, then what we're doing is we're using BGP route peering, and we're going to peer our cross-region branch routes, so we can peer our regional branch routes into the Google Cloud Router and then between the Google Cloud Router. So now we have branch-to-branch connectivity. We do the same thing with Google VPC routes as well. So the workload routes, we basically, those all peer in to the local Google Cloud Router in the region, and then we basically peer via BGP to the SD-WAN clusters, and from there we can redistribute the workload routes into the branches via BGP-OMP redistribution, and vice versa, of course, branch routes into into Google Cloud routers, into the Google Cloud Router in the region, and then NCC distribute those routes between the different regions. Okay.
Quick question here.
Yeah.
Are the SD-WAN devices here, the virtual ones that sit in GCP, are they just at the edges, or are they in every VPC that you have? Like, because on here I'm seeing them like, I see one in Asia South, I see one in US West 2. Are you doing it pretty much one per region, or is it every segment? Yeah,
we're going to do one in the regions of interest to the customer. Absolutely. So you see that transit VPC in the bottom. You can think, of course, Google VPCs are global in nature, right? So the customer might have a region where they have a bunch of branches. They're going to put a Cloud Hub there, and that's going to give them local SD-WAN termination, there, and then basically they can route within the Google infrastructure. They can route to workloads in any other region, or they can route to another Cloud Hub that's in another region. But the idea, yes, is that the customer will put the Cloud Hubs in the regions that they desire.
So really, this is extending SD-WAN to the edge, and then you're using native constructs to get around in the middle.
Yes, but hold that thought. Yeah, absolutely. So we're going to use those native constructs in our use cases, but we're also going to do some other nifty stuff there too with SD-WAN. Okay, because once we have this native connectivity and using Google Backbone and NCC Hub, we can actually throw an SD-WAN fabric over top of the core, or the Google core as well, and that's a very interesting proposition. So that's a good segue to talk about sort of the next slide, which is kind of give you a sense of the use cases, right? So if we're talking here about the main use case, which is kind of site to cloud connectivity, I showed you how routes are going to be established. Once we have those routes established, we can then basically connect sites to workloads through in any region. So you, of course, if you're coming in through US West sub region, you can access Google workloads that are in that region directly, of course, but you can also access specific workloads that might be in another region also directly, right, through the Google Backbone. So in this particular case, we're kind of using native mode, because when we hit the Cloud Hub, we're going to go to the workloads, but we're going to go to the workloads. We're going to be off the SD-WAN fabric, right? So the SD-WAN fabric is kind of facing the branches, and then we have what's called the service side on SD-WAN, which is basically facing the data center. So these purple lines that go up to the workloads, that's basic. That's the basic Google underlay BGP peering type of access that you would have to the workloads. Okay, so we're going to be on the Google fabric natively at that point. Now, interesting case we can do here is now that we actually can share branch routes, from different regions across the Google Backbone, and we can actually dynamically advertise those routes between regions, which was not allowed in Google infrastructure by terms of service in the past. Now that we can do that, we actually can connect sites up. Site to site and do site to site networking through the Google Backbone, but we can also run the SD-WAN tunnels across that backbone as well. So now what you have here is you have a multi-hop SD-WAN network. All right. So in the past we've had single hops. So generally speaking, SD-WAN is a sort of a single hop CE to CE type of tunneling technology or fabric approach. This now breaks that paradigm. So we're going to actually do a multi-hop fabric here. So we're going to get you in one set of tunnels into the Cloud Hub, and then from there, your destination address may take you to a workload, or it may take you to another branch, right? So we're going to pop you into another tunnel that runs across the Google core, and then basically pop you out at the right region and then take you to the branch the rest of the way via tunnel switching. Or I don't want to say tunnel switching because we're doing a full route lookup each time, but you get the idea. We're basically hopping from tunnel to tunnel. So we've kind of taken a new paradigm with the fabric, the SD-WAN fabric here, and allowed a more hierarchical design to be put in place, okay? And so that's kind of a cool new feature that we're enabling. And we think the benefit here will be for customers just to have a single consistent way to manage policy, networking policy through cloud access as well as cloud backbone, rather than having to go into the native mode in the cloud and then work through Google CLIs and things like that to basically create the internetworking across the backbone. It's easier, we think the customer can then manage policy in a centralized way in vManage, and we go in and we program effectively the route tables that we need. The other benefit of this is it keeps the customer routes out of the Google infrastructure. So all of the customer routes in this case are going to be stored in vSmart. So the branch, the actual customer branch routes they'll be stored in vSmart. And that also alleviates some of the route scaling issues that you see in the clouds today. I think we're limited to a few thousand routes or a few hundred routes in some cases. So the good news is, at least with this architecture, to make this happen, you only really need to carry infrastructure routes in, just enough routes to form the tunnels. We can keep all the other routes in the overlay for the most part. All right. So that's a couple of advantages of this architecture. So let's talk now about the idea of being able to cloudify your WAN aggregation, lifting and shifting your SD-WAN aggregation itself to the cloud. So we talked about the cloud edge, being able to terminate SD-WAN directly in the cloud edge, but we know that the middle mile is becoming increasingly important in networking today. Colo networking, all of the SaaS providers, all of the IaaS providers are providing edges in the colos, and this middle mile networking becomes very important. So what we're doing here with this new product is the Interconnect gateway is we're giving you that ability to move that SD-WAN aggregation point, which might have been in your private data center in the past, right? Where you aggregate SD-WAN traffic and then maybe plumb a direct connect circuit into the cloud to get your cloud access. We're saying, hey, we can take that and move it into a colo provider and basically host it there. And that's what we're doing with the SDCI providers. And the beauty of these software-defined cloud interconnect partners is that their networks are programmable, API programmable. So we can give a cloud-like consumption model, cloud-like behaviors in the actual WAN network itself. So no longer thinking about racking and stacking of physical gear, procuring of connections, and the time that takes, and also the fact that you have to procure those for long terms, right? This brings a more cloud-focused or cloud-native consumption model. So we can turn up circuits on demand, we can turn up the hosted service, we can tear it down, just like you can perform experiments and in the cloud, with new applications and VPC infrastructure. If it doesn't work out, you can tear it down and start again or do something different. We're trying to bring that kind of consumption model here to the cloud. You need something temporary, go ahead. You need extra capacity, add a couple more ports to the service, right? And to basically bring that consumption model in, we think is going to be a very key going forward, as we move towards cloudification of networking itself, right? So this is the first step in doing that. So we have this SD-WAN gateway service that we're providing at co-location facilities. The first partner that we're coming to market with is Megaport. We'll be in about 22 metros, 41 different co-locations by the end of the year. And then again, this is the hosted service with our SD-WAN, our SDCI partners. So it's for on-demand metro site aggregation and on-demand network and cloud connections. So once we put this gateway in place, we have full automation of the service, and we'll talk a little bit more about that. So let's look at a specific use case to help ground us here. So if you look on the left-hand side, I've shown a similar diagram to what we showed before. The Interconnect gateway is front and center here. So the idea here is you have first mile access providers, and right now we're basically those first mile access providers have to be ISPs. So if the customer is looking at hybrid WAN, they might want to look at a dual ISP connection coming in here, right? That's a possibility. They might want to use this service as, hey, this is going to be my better than internet service side of my SD-WAN, or my alternative to private MPLS service. I want to, more programmable, more flexible, more on-demand infrastructure. Okay, so that's kind of the thinking and the use cases here. But the idea here is we can basically aggregate via the internet first mile into the interconnect gateway, and we're going to have an SD-WAN fabric connection there. So we'll have our SD-WAN fabric overlaid on top of that. From there, we basically can, we're basically using vManage, which is our SD-WAN orchestrator, for integrated control of the service creation, for creating the on-demand cloud direct connects, and as well as giving you the consistency of those network abstractions. So the ability to use OMP everywhere, the ability to manage centralized policy with vManage and vSmart, the ability to use data policies here, bringing that capability into the colo, all right? And then from there, we support a range of different connection types. So we support both the hosted VIF style of connections. We support hosted connections for higher bandwidth as well. All right, and we have both public and private side connections there. And I want to point out as well, we're the scope of automation. So in our automation today, we are automating right up to basically to the VPC, the workload level. All right, so we're able to basically orchestrate all of the connections and all of the setup of all those elements, and plus we're able to also orchestrate and do segmentation where it is supported by the cloud provider, and allow you to basically connect up your workloads into segments that are in your SD-WAN as well. All right. So the way I like to think a little bit about this is in before with SD-WAN, we kind of said, hey, go build your underlay, buy an underlay from partner or SP, build it, get it ready, then we'll throw the overlay on top. This gives us the ability to basically go to the customer and say, look, sign a contract with us, pick a partner that we support, and you can build both the underlay and the overlay at the same time on demand. So we're hoping that this is going to catch on really well, and it's going to be very popular. So all this is driven through vManage automation and APIs that we have into these software-defined cloud interconnect providers. So the next use case, we're taking it to kind of the next level, right? Again, goes to this hierarchical multi-hop tunnel view that I was talking about with the Google backbone, right? So again, at the bottom of this diagram, you're seeing, okay, the standard thing we just talked about a minute ago, which is SD-WAN fabric access to the interconnect gateway that's hosted in Megaport, and then, of course, in the future, release Equinix as well, right? But just hosted at the SDCI provider site. From there, we will be able to basically do internetworking between the colos that's also SD-WAN, an SD-WAN fabric. So we can throw an SD-WAN fabric overlay on top of the different colos where you have these edges, okay? From there, then we can do SD-WAN internetworking between the colos, and then that helps us getting from branch to branch, just like we had shown for Google, except this is a cloud-independent way of doing that, okay? So we can do this we have this inter-region connection provisioning and abstraction via APIs, and we'll show you how that abstraction is in our GUI. And also, this is again talking about that hierarchical SD-WAN core, right? So the core SD-WAN, even though it's all part of the same overlay, is basically separate routing, area from the regions. So that's the idea, is to simplify the core routing and the routes that we distribute, and give you that hop by hop choice of where you're going. All right, and you can see here going into the workloads, one change as well. This is something we're going to be bringing in a future release as well, as compared to the slide I showed you just a minute ago. Before, up at the top, we saw that we were plumbing the direct connect gateways right into the TGW, the express route, we were plumbing that right into the vWAN hubs, right? In this case, we're also looking at being able to basically, if you had a cloud hub in there and you were coming in by a regular internet circuit, we could plumb this SDCI or this SDCI part of the hybrid WAN into the cloud hub as well. So you basically have a dual connection coming into your cloud hub, and then you go up through the TGW to the workloads from there. So the idea here is to give you that, again, to extend that SD-WAN control right to the cloud edge for both the quote unquote public internet side and the SDCI side. So to really give you the original sort of SD-WAN experience that you could have had going to the cloud with these SDCI providers. All right. The goal here, of course, again, is to have the full traffic, and we should support full segmentation and traffic engineering and policy control of SD-WAN right up to the cloud workloads. Again, with a single portal for service creation and provisioning. All right. So I just want to touch on one thing before we move on to the demo, if I can. We recently released a new 8200 series product called the 8200L. It's kind of tied in with the cloud, so I want to make sure you guys were aware of it, right? So this is really a very compact, optimized platform for cloud network applications. It's really built for the cloud consumption model, right? So the idea is that this is a very high performance, small form factor branch router that doesn't have it's not positioned for integrated security and things like that, like some of our more higher end ones, higher end boxes are. This one is positioned for high scale and high scale data plane performance. So we got twice the data plane performance, twice the IPsec performance, and about 9 times the SD-WAN tunnel scale that we had on our previous 4321 router, for example, that this replaced. Okay, so it's really scaled up for fabric access, and then it's meant to where services are being delivered in the cloud. So that's why we kind of have here SASE compliant security. But the idea is you're connecting up to SIG for traffic that you're offloading to SaaS, and then you're basically getting your SD-WAN connection into our other cloud services like the Interconnect gateway or the Cloud Hub. So that's what this guy's kind of targeted at, and we've optimized the data plane and the performance for lots of tunnel scale and fabric scale.
All right. Well, yeah, good afternoon, everybody, and thanks, Steve. So I'm going to walk you through a quick demo of what what Steve was talking about. So specifically the Megaport workflow that we're introducing with 20.5, among other things. But as you all know, this is vManage, right? This is the same dashboard that you guys were looking at just a little bit earlier. So I'm going to go ahead and head over here into the configuration workflow, and I'll head on down to Cloud On-Ramp for multi-cloud, down here in the very bottom lower left. You'll see this drops me into our multi-cloud dashboard. This has been available since I think 20.3 and 20.4 and now 20.5. We introduced a new tab up here for the very top. So this tab is where you'll find new things, specifically the Megaport integration and things like Equinix, like Steve was talking about. So just to kind of walk you through what this looks like from a customer perspective in order to be able to light up a service like this or light up regional aggregation points through Megaport or through Equinix. The first step that you're going to have to do is associate an account to Megaport. So basically what we're doing here is or the idea here is that a customer really doesn't have to have a relationship with Megaport. Once they order the service through Cisco, we can generate or send them an email where they have a kind of an onboarding email so they can generate a username and password. They'll create that username and password, and they can go in here and select Megaport as their provider, provide an alias for their account, a description, and then provide the username and password that they selected. Now, what this is going to allow vManage to do is programmatically reach out to any of the Megaport co-location facilities that are participating in this ecosystem and be able to make API calls to those facilities in order to spin up or spin down circuits, Catalyst 8 KVs, and things like that, things that you heard about from Steve's presentation. So once we have these credentials saved, now I've already got a couple credentials saved here, so I'm going to just leave that as it is. You'll notice over here on the right-hand side, as soon as we get that credential up and running, you'll see where it shows me as having 18 regions available. Now, like Steve said, we're going to have about 22 metros. So you can think of regions as just like metros. We're going to have about 22 metros and I think 50 some odd data centers or co-location facilities by the end of the year. And Megaport keeps adding new data centers almost on a weekly basis. So we expect that number to continue to go up. But basically, if you click on each one of these, or you click on this 18 right now, just in this demo setup, we can see some of the metros that we're participating in today, just for sake of demo. So once you've got the your credentials set up, the next step is to head over here under Interconnect Global Settings. And basically, what this allows us to do, what this screen allows us to do is customize a little bit of our deployment if necessary. So first off, you'll notice here we have, I'll click on that edit button there. We have Megaport as our provider. We have an option to choose our software version. Now, Megaport will maintain these software versions for us. So every time we release a new version of SD-WAN software or SD-WAN code, you'll see a new version pop up here. Now, nothing precludes the customer from doing any kind of upgrades or downgrades or whatever they want to do. In fact, they will own the router entirely from a configuration perspective. Megaport is just hosting it for us in this case. But they can select the software version that they'd like to run. They can choose the instance size. So in essence, what this is if I could create an analogy to something like AWS C5.large or C5.extra large, this is essentially how much compute you would like to default each of those Catalyst 8 KVs for. Right. So depending on how much bandwidth you think you're going to be pumping through each one of these aggregation facilities, you can just simple, small, medium, and large, pick the size of instance that you want. Large, small being somewhere around maybe 500 megabits to a gig, medium being around 2.5 gig, and large being around 5 gigs or more, depending on the amount of bandwidth you want to pump through it. When Steve was talking about the backbone interconnect, right, where we're utilizing Megaport and or GCP or whoever else as a backbone. So for region-to-region connectivity, where we're not touching the cloud, we're just going from one region of the world to the other, but leveraging Megaport's backbone to do that, that's where we can also choose our interconnect transit color. This is what allows us to create a separate set of tunnels just over the backbone so we can more finely tune some of our routing policy as well. You can see here we can also choose our BGP ASN. This is for when we're peering with AWS, Azure, GCP. We can kind of tune what BGP ASN we want to use in case we want to get that specific with some of our route policy. Now, heading back real quick, that's kind of the first step, is just to set up your credentials and set up some of your basics there. The next step is to discover the host networks, right? So if we choose AWS as our provider here, basically what vManage is doing is going out to AWS and identifying all the different VPCs that we own under my AWS account that I've put into vManage previously. So you can see these are all the different VPCs that I own. And what I need to do is select the VPCs that I want to make available to this workflow, right? So I can choose several of these if I want. The next option is to add a tag. And basically what this is I will check this box right here, which more or less just says that all these VPCs, I want them to be available inside this workflow so that I can build an AWS Direct Connect through Megaport and touch each one of these VPCs or make them available to the Megaport backbone so that I can leverage Megaport to reach them. Okay. Now, next step is to create our gateway. So once we've got our credentials set up and we've mapped our VPCs that we want to use, we can create our gateway. Now in this case, this is literally vManage going off and spinning up a Catalyst 8 KV out in the Megaport facility that we choose. So again, we'll just give it a name, give it a description, choose the account that we want to authenticate with Megaport with. What location do we want to spin this up in? Like Steve said, depending on the regional, how close, regionally speaking, where our big pockets of users are within the organization. If I want to light up one in Tokyo and I want to light up one in Atlanta, I want to light up another one in Sydney, maybe one on the West Coast somewhere, I can choose that location out of this listing here based on those metros that you saw previously. So I'll just choose Atlanta for the sake of a demo. And then I need to choose the Catalyst 8 KV chassis that I want to allocate to this particular metro. So I'll do that. You'll notice I can also customize this if I'd like to choose a different software version or a different instance size for this metro. So if you have some aggregation facilities where you think you're going to be pumping a little bit more bandwidth than other facilities, you can do that. And then once you click the add button, like I said, vManage is literally going to go out, send a REST API call off to Megaport, ask Megaport to allocate a certain amount of virtual CPU, some RAM, some disk space. We'll spin up a Catalyst 8 KV. And about 5 minutes later, what you should get is a listing similar to this, which is more or less an SD-WAN router that has come up on the internet, has joined the SD-WAN fabric, and is now ready. It has now presented itself as another branch off your SD-WAN fabric. So now you can start pushing traffic to it. The last and final step that you need to do, now that you have an active gateway that's joined your SD-WAN fabric, is here under Interconnect Connectivity Management. Now this is kind of where the rubber meets the road. This is where the magic happens, so to speak. So we'll choose our Megaport account, and we need to choose the source gateway. So we need to choose the gateway where, for instance, if we want to build an AWS direct connection off somewhere into AWS or an express route or something like that, or even a backbone connection from one region to another, let's choose the source gateway. So in my case, I've already got a gateway here in the US spun up that I'm going to use. So I'll choose that. I'll go ahead and click on Add Connection. And you'll see we have two options here. One is to connect to the cloud. The other one is our backbone service where we can create an edge connection. So let's just do that one real quick. So we'll choose Megaport as our provider. Again, give it a name. Oops. And then we need to choose the destination. So as a backbone, I'm creating a connection from our Atlanta location, our US gateway, to Tokyo, or to the Asia Pacific gateway that we created previously. And then we simply tell it how much bandwidth we want. And this is in megabits per second. You can go anywhere from one gigabit all the way up to 10 gigabits or 250 meg, depending on how much bandwidth you think you're going to need for that connection. The idea here is to lower the latency, lower the hop count, and ultimately provide you a more premium connection to get from point A to point B. It's as simple as that to create a backbone connection. Now, in the last 30 seconds that I have here, let me show you what it looks like in order to create a cloud connection. Like Steve said, we have a couple options here. If we choose cloud, and AWS is our provider, we'll give the connection a name. Like Steve said, we have a couple different options that we can connect to AWS or any other cloud service provider with. We can use hosted VIF or we can use hosted connection. For the purposes of a demo, I'm going to choose hosted connection because it gives us a few more options that we can play around with and demonstrate. If we click on hosted connection, I'll choose my account that I've used previously and go ahead and click next. Now it wants to know, do I want to connect to private resources, public resources, or do I want to connect to an AWS transit gateway? So you have the option. So again, for the purposes of the demo, I'm just going to choose transit gateway. It wants to know what region that we want to connect to with this direct connection. So again, we're starting from the US gateway in Atlanta. Now it wants to know where's the other end of this direct connection going to go. In my case, we'll just choose Northern Virginia, US East. How much bandwidth do we need for this hosted connection? We'll say a gig again. You could go up to 10 gig if you need to. And then we'll choose a direct connect where it's actually going to land within that within US East. So in my case, I'll just choose DCG1 since I've already created that previously. But notice you can also leverage vManage to create that direct connect gateway for you if you're not familiar with AWS. Last but not least, you can customize some of your settings as far as BGP peering and route redistribution. Everything we learn off of this connection, we can drop it into a specific VRF, in this case, VRF 10. And then ultimately, when we click on this transit gateway button here, I can choose the transit gateway that I want to connect to. So in my case, I'll just choose one of these guys here. And then I need to choose the VPC that I want to attach to that's attached to that transit gateway. So in other words, we're building a direct connection from Megaport to a direct connect gateway sitting in US East, which is attached to a transit gateway, and that transit gateway has the VPC that I'd like to attached to it. Last but not least, I can choose allowed prefixes. This allows me to do some basic route filtering and some basic aggregation. So all the prefixes I'm learning off of AWS, if I want to, I can aggregate those into a single prefix or just a few prefixes in order to save on routing table space, so on and so forth. The idea behind this, though, is if I'm sitting in a branch router and I do a show IP route VPN 10, just for sake of example, I should just automatically start seeing routes pop up in my routing table without me having to really get into AWS and mess with any kind of redistribution with BGP and OMP or anything like that. It's designed to be as turnkey as possible to give you a premium connection from your branch all the way into AWS.
We're talking about using these devices in aggregation points and towards the cloud. And we're seeing these connections become larger and larger, but we're talking about virtual devices, and there's always limits on virtual devices. Yeah. So what are our limits in solutions like this? Like what is our top end? How much throughput can we get?
So nothing precludes you from creating multiple circuits. Now, I mean, there's a cost factor there. I get that, but you can. Megaport has ample connectivity to AWS, and I don't want to be misquoted on it, but it's several tens of gigabits.
I don't think Megaport and their connections are going to be
exactly
the throttling point here. Yeah.
So what we've tested to on our Catalyst AKV, in real world application, you're probably going to be looking at somewhere between, I would say, 5 and 7 megabits, 5 to 7 gigabits per Catalyst AKV. Okay. So more than likely, depending on how far you want to scale, you'll probably end up, you'll spin up at least one, and depending on how much you need to scale, you might spin up 2 within a single metro. And then those 2 we can utilize something like ECMP load balancing over the SD-WAN fabric to get traffic to that colo and then onto the direct connect for you.